Hello. If you're not getting me, you can be what? You can be telling me. Are you getting me?
Yes, I can get you.
Okay, okay. I lost my connection.
Cool, cool.
Mm, yeah, I lost my connection. Uh, so yeah, so if you have any question, you can ask. If you have anything, you can just interrupt me and you ask your question. You can stop me, then you ask your question. So now we're going to start with the definition. So what is coordinate Cartesian? So doesn't plan or xy. So doesn't plan. We have our plan, which is uh or x y. I don't know if every one of you are getting me clearly. If you're getting me clearly, show by raising a hand, because there are some who are having some difficulties. Yeah, those who are getting me clear, they can show by raising their hands. Chumba Makasa, can you get me clear?
Yes, I can get you, Monsieur.
Okay, okay. Yeah. I don't know if Fortune, you can get me now. Fortune Perry. Yeah, so those who are not able to get me clearly, I think the best thing is after the recording, I'll just send the video in the group. Yeah, for those who are having some problems, who watch the video. Yeah, because everything will be recorded, the things which you are going to learn today. So yeah, so I'm going to continue. So it's we're under our definition. So Danzan plan, which is in a plan, or XY. So in a plan, which is or X, Y, un point M, which is a point M, est rappelé par ses coordonnées XY. So we see that the point M is marked, rappelé, just it is marked it means by its coordinates xy. So we see that this point M is marked by its coordinate what, which is x. If you see here, it's showing the small x. So the small x and the small y. So it just means that I'll move a distance from O to this distance, which is x here. Then from x to this distance, which is y here. So OX and OY, they are just the distances, which you can give them numbers if you want, 10, 9, 5. Yeah, it depends which numbers you have been given. So it's just the same thing which you did in Zambia, where they can give you the x coordinates, which is maybe, for example, they give you 10, and the y coordinate, which they give you, for example, 12. Then they tell you find M where these 2 points they are meeting. Just the same thing. So that's what is explaining here. And yeah, correspondait à la mesure algébrique de la projection de M successivement sur les deux axes du rappel. So here you see that these coordinates or these coordinates xy, they correspond at an algebraic projection, the M, which I was talking about, where when you use this point, you can get your M, and this M is done, or it's what is in two axes of the rappel. Rappel is just the other name for X or Y plane. So you know that the two axes which you are talking about is the grand Y and the grand X. Then the coordinates is small y and the small x. Hello, is there a question? Yeah. Donc, ces deux coordonnées sont de même nature et homogènes à une longue. Yes, is there someone with a question? Please, let's try to switch off our mic. Yes, disturbing. Yeah, so ces deux coordonnées sont de même nature et homogènes à une longueur. So we see that these two coordinates are of the same nature, and they are the same in what? In I can say in size. Yeah, they are the same in size. So we're going to yeah, so I think now it's muted. Yeah. So we know that the base of la base orthonormée associée à ces systèmes de axes est notée EX, EX, which is a vector EX and a vector EY. So the base orthonorm. So when you just talk about the base orthonorm or the base is simply the direction. So there's the direction and the distance. So when you talk about the direction is noted as EX. Where is it going? EX and EY. So EX, it means it's going in, if you see where EX, where this arrow is going, that's where the direction is going. So you are going from O to M. Then EY is basically on the y-axis, where you're going to from O to the what? To a small y. So this is the direction. So the base, when we talk about the base, we're talking about just EX and EY. And when we talk about the coordinates, we're talking about the distance. This is the small x and this is the small y. So those are the things which basically you just have to know here under coordonnées cartésiennes. C'est une base qui ne change pas au cours du temps. So we know that you should know that this base, the EY and the EX doesn't change because they're always moving on the same, on the what? For example, EX is always moving on the what? X-axis. It will never move away from the x-axis, and the EY, the direction is always on the y-axis. So it will never move away from the y-axis. That's why they're saying that c'est une base qui ne change pas, which means it is a base which does not change en cours de temps, which it is a base which does not change during, I can say, during the time. It doesn't change during the time. So, and we see that this vector garde la même direction, la même sens, et la même nom en cours de temps. So we see that this vector, which is EX, EY, it always have the same direction, which is, if it is EY, it will be always moving up. EX, it will be always moving towards the right. Yeah, towards the right. Or if there's the yeah, it will never change. If it is towards the right, it will be moving towards the right. Yeah, it will always be moving towards the left, which is, it will get them the same direction and the same sense. The same sense meaning it will always be, it will never change. It will always have the same. I can say it's just the same as the sense is just the same as, I can say there's not much difference between direction and sense, meaning it will always be looking at the same way. It will never change where it is looking. That's the sense. Then direction, it will always be moving in that constant direction. The direction will never really change. And le même nom, it means the même standard, like the way it's moving, the speed is what, the direction will always be, I can say it will always be the same. On dit encore que la base est fixée dans les rappels. Here we see that this base, when you talk about the base, we talk about EY and EX is always fixed on Y and X. It can never move away from, EX can never move away from the X plane, and EY can never move away from the Y plane. So that's what you have to know. So, ces vecteurs peuvent être présentés n'importe où dans l'espace, mais en général, ils sont représentés en point origine 1. So they're saying that EX, this EX, the base EX, which shows the direction, and EY, which shows the direction on the y-axis, and EX in the x-axis. These are, they can be placed anywhere. If I want, I can place it here on top. If I want, I can place it here. For EY, if I want, I can place it here on top. The direction, if I want, I can, for EX, if I want, I can, yeah, in case of EX, if I want, I can place it here. But the most appropriate way, or the most way which is advised to do, is to just place it closer to O. So my EY, you have seen my EY, this direction is just closer to O, then EX is just closer to O. That's the one which is preferred most of the times. So yeah, so that's it under Cartesian, coordinate Cartesian. So coordinate Cartesian, basically, you just imagine the X or Y plan. Just imagine the X or Y plan, and you are told to find a point M. So they have given you the distance, which is X, then the distance, which is Y. Then you are told to find the point M. That's how you should imagine it. And yeah, like that, if you have that knowledge of imagining it like that, you won't have any difficulties, and you know what to do and how to answer. Because basically, most of the time, they won't ask you define what is a coordinate Cartesian. No, they'll ask you, how have you understood about this thing? So you have to know the coordinates, you have to know the base. The base is actually the vectors, And if you know these things, you can able to answer any question when you are given something which is like a plan, which is, for example, a point which is represented in a rectangle, a square, all those things. Like those things are planned there. They have got the when you draw a rectangle, basically it's something which is it has what straight lines, and it's something which is not in the form of a circle. I can say so. It's not in the form of a circle. It's something which is straight, and the points like those ones you can be able to calculate this what this you can be able to calculate this surface area, its volume, all those things. So basically, we learn about these coordinate Cartesian, coordinates Cartesian, coordinates polar, for us to know how to derive the formula of calculating the surface area of a circle, or the surface, the surface area of, I can say, a rectangle, the surface area of a cube, the surface area of a circle, or volume of a circle, volume of a cube. So this is the reason why you have to know these coordinates, how to place them, and how can you calculate this what is surface area. Yeah. So when you go down, we're going to see more definition. We're still on coordinate Cartesian. We're going to see more definition on coordinate Cartesian. So, considérez un point M appartenant à plan affini OXY muni du rappel RXY. Yeah. So, considérons un point M appartenant au plan affini OXY muni de rappel RXY. So, here is just saying that let's consider a point, which is M, which is this point M, which appartenant, it means I can say, which is found in a plan affini or XY. So this point is found in a plan which is X or Y. This is the point M, and which is defined by the rappel, which is what? XY. And we have O, which is O, AX, and the AY, the direction. Soit, now we are going, soit it means let XY, les composantes, dans le base de Cartesian EX, EY, the vector R is equal to what? OM. So they are saying here that soit XY, here when they're saying XY, they're talking about the small x and the y, which are the composant of composite coordinates. They are just the same thing, but the difference between composant and coordinates or coordinates is that a composant is something which defines this point M. For example, if I move this point M at M prime, let's say here, for example, you see that the Y here will become big, and the X here will become what? It will increase. The Y will increase, the X also will increase, which means that this point M depends on Y and X. And each time I increase X, the Y also increases. Each time I increase X, the Y also increases. So it depends on what? On X and Y. So here the composite is what? X and Y, and the coordinate is also X and Y. You are going to see the clear difference between the coordinate and the composite when you go to the next one, to coordinates polar, where you are going to see it's different, because here under coordinate Cartesian, the composite and the coordinates, they are just the same, because the coordinates is just xy, is xy, and the composite is also xy, because the point M is defined on xy. Each time I increase xy, the point M also it also increases. So you have on vector R, which is OM, which is, so on vector R, so R, this is, OM is this one, OM. So here, this is on vector R. On vector R is a vector which is moving from O to M, which is, yeah, so you see that, that's why they're saying that on vector R, which is OM, let's define vector R, which is OM, then this R, which is equal to OM, is equal to, for me to have OM, what do I do for me to have a vector OM? What do I do? It means I have to move X, the distance of X, in the direction of EX. That's why you are seeing OM is equal to the distance X times the direction of EX, the vector, plus the distance Y times the direction EY, which is what? The vector. So this is how you can get your what? Basically, this is how you can get your what? Your point OM. How have you moved? Sometimes they would say, how did you move to reach this point M? So for you to know the movement, you have to know the direction one and the distance in which you have moved. So what is the direction? The direction is EX, which is EX, and the distance which you have moved is what? OX, which is the small x here, plus C. So you have moved this distance. Then for you to move from here to M, you have moved the distance of Y, which is Y, plus C, the distance of EY, the direction of what? EY. You are moving in the direction of, because you can move a direction which is up or direction which is down. So you are moving in a direction which is what? Up, which is M. So it will be X times EX plus Y times EY. For you to find what? The vector of OM, to find the direction, how OM had moved. So most of the time you start with X, then you go to what? To Y. I think that one is also the similar one which we do if you are given coordinate the X, coordinates of X, which is X and Y. First of all, you move under the X-axis. After you move under the X-axis, you move now in the Y-axis for you to have the point where for you to know the point, to find your point, you move the X-axis, which is, for example, they say X is equal to 10 and Y is equal to 12. You move 10 and you move up 12, then you find your point. So this is the same thing here. It's just X, which is the distance which you are moving, then EX, which is the direction which you have been told to move, plus Y, which is the distance which you are moving up, and the EY, which is the direction which you have been told to move. So U, which means where X is equal to OM times EX and Y is equal to OM times EY. How does this one come up? So yeah, how does this one come up? So for this one, I made something for you guys. I think it's there. Yeah, are you able to see my screen? Hello? Are you able to see my screen?
Yes, but it's still on custom. Okay, yes,
What?
It's
I can
changed.
get you.
Yeah.
Yeah, it has changed.
Yeah, we can see it.
Oh,
Yes.
okay. So here I'm just going to explain to you where did the X or M times EX come from? Where did it really come from, and Y is equal to OM times EY, the vector EY. So this, when you see a R on top, it means the vector. Vector meaning is, I think in Zambia we define this, the quantity of what? Magnitude and direction. Magnitude and direction, where there's a direction and also a magnitude. The magnitude is distance. So how did they get X is equal to OM times EY? So you know that this is the direction AX, and this is M. So you are forming like a triangle. If you see here, if you see a proper, you're forming like a triangle, and you have EX and what? EX, EX, which is the direction, and the OM, OM, which is the distance. We have OX, which is the distance here. So for you to actually find how they found OM times EX, you can just use I think you know this one, Sokatora. Yeah, you have done it in Zambia, I think so. So but here we're going to under Sokatora. So you see here that the angle is made here. The angle is made here, but basically under with a point which is with a point which is not in a circle, which is not defined in a circle, like under coordinate Cartesian, we're not talking about circles here, we're talking about shapes like rectangle, squares, those shapes. I'm not talking about shapes like cylinders, spheres, circles. No, we're not talking about those. So here, it means that for you to find your X is equal to OM times EX, it means you have this one, which is X, this one, which is OM. And imagine there's an angle here. Yeah, there's an angle here. So you have your EX is equal to, this is the X, this is the OM. OM is always hypotenuse. OM is always what? Hypotenuse. So your EX is equal to your X, which is your adjacent, your X over your OM, which is the hypotenuse. Therefore, for you to have X, you just have to do some cross multiplication, which will be X is equal to OM times the direction. Then just the same with EY. EY, this is our EY here. So for our EY, we have said that OM is always what? The hypotenuse. So EY is equal to Y, which is this distance here, divided by the hypotenuse, which is OM. So there will be Y divided by OM, and when you do cross multiplication, you have this formula. So these are the formulas which you just have to know them by heart. You have to have them by heart, and you see how you use them. Yeah, how you use them when you come to calculate, like especially when you come to start when you start learning Chimbi electric, the charges, force electric, those things. When you start using those things, you're going to see how to use them. So these things are just they just teach you so that you have an idea how you'll be manipulating, how you'll be doing the calculation when we come to do the actual thing, like when you come to do the actual module of electricity, where you have to find the charge, the Chimbi electric, those things. Yeah, so this is where the X comes from, and this is where the Y comes from. Yeah, so this is where you see X is equal to OM, EX, and Y is equal to OM, AY. And you know that XY is a pair coordinate Cartesian to point M, meaning there, if you move X and the small y, you have your M. Now we're still under the coordinate Cartesian. Now let's see what happens when this point deplaces, like when this point moves from one point, when this point M moves from one point, which is M, to another point, which is M prime. What really happens? So we see that it says here, lorsque ces coordonnées varient respectivement des quantités élémentaires dx et dy, le point M se déplace en position infiniment voisin M', the coordinate x plus dx, y plus dy, the vector, the coordinate x plus dx, y plus dy. So imagine we have the point which is here, which we have already talked about, the x and which is defined by x and the y, and I move this point to another point which is m prime. What happens here? It means that I've changed my what? My x, and I've also changed my what? My y. So the actual, it's like the actual y which I have here, I've added another y, and the actual x which I have here, I've added another distance x. So you have moved from what? From one point to another point. So that's why you are seeing that the y, which has moved from m to m prime, you have y plus dy. Dy is, you know that when you differentiate something, it's like you are, when you differentiate something, it's like you are moving from one place to another. That's, I can say, that's the phenomenon of differentiation. When you do differentiation, you move from one point to another. That's why you are seeing dy. Dy here is just showing the movement which you have made. So you have moved from y to dy. So y plus dy, and you have moved from x to dx, which is your x, your actual x plus the movement which you have made, dx. And now for you to find the coordinate, or I can say the coordinate, or the vector. For you to find the vector mm prime, the vector which mm prime is the vector which you have moved from here to here. How, for you to know, to find the vector which you have moved from here to here, you know, basically, for me to find the vector which I know, first it moved from O to M, and secondly, it moved from what? M to M prime. So you know, it's logic for you to find the vector which is M to M prime. It means I have to subtract what? I have to subtract the distance from O to what? To M prime, minus C, O to M. That's what I have to do. I have to subtract O to M prime and the O to M. So the distance from O to M I know is X and Y, and the distance from O to M prime I know is Y plus dy and the X plus dx. So how do you find, how do you come up with this formula now, the distance from M to M prime? How do you come up with this formula? So if in coming up with this formula, yeah, I wrote something which is I think to be simple for you to follow. So how do you come up with this formula? So we have said that there's for you to have the distance M prime, which is, it has moved from M to M prime. What do? You do the from O to M prime minus O to M. So O to M prime, which is O to M prime, which is X plus dx, X plus dx, and times the direction Ex prime. So this one basically is this one here. Let me just, yeah, it's just this one. For you to have OM prime is OM prime, first it will be X plus dx times the direction, which is X. So the direction doesn't change because you're moving in the same direction. Plus plus, this is, since you are dealing with M prime, it will be Y plus dy brackets times EY. Then minus OM is X, EX. It has moved X in the direction of EX, plus Y, it has moved in the direction of AY. So this is just here, which is the same one here, which I was which is I can say which is the same one here. If you check it, you see x plus dx brackets ax, which is for OM, plus y plus dy brackets A1, and minus OM, which is just the same, the ordinary distance, which is x times the direction AX plus y times the direction AY. And when you check these, you see that there's AX, which is common, AX, which is common, there's AY, which is common, AY, which is common. And you know, you group the like terms together. So the EX, you know, if you remove the brackets, it will be negative X EX minus Y EY if you remove the bracket. So negative EX, you take it, you group it with EX, the direction, because they have got the same direction. So it will be X plus DX minus X EX plus Y plus dy minus y ay. So you know, you see here that the y and the y will cancel out, the x and the x will cancel out, and you have dx ax plus dy ay. This is actually the what the this is actually the formula which you have here, dx ax plus dy ay. So basically you just get your y plus dy, yeah, open brackets, y plus dy, close brackets times ex plus x, x, no, x plus dx, yeah, open brackets, x, open brackets, you start with, you start with open brackets, x plus dx, close brackets, ex, the vector ex, plus y plus dy, close brackets, your vector what? Your vector ey minus open brackets x ex, the vector ex plus y, the vector ay, close brackets. Then when you do your calculations, you see that it will give you this. So this is when you see m prime is the displacement which you have moved. They can tell you to calculate the displacement of m to m prime. How has it moved? Calculate its displacement m to m prime. And this is how that's how you calculate the displacement m to what? To m prime. No, here it says, ne autre chose que la différence d'OM, de OM, yeah, no autre chose que le différentiel d'OM, de OM, relativement on rappelle RXY, on l'appelle vecteur displacement élémentaire DL. So, other things, other things than the differentiation of OM. Differentiation meaning just the movement of the M point to M prime. There's also what we call déplacement élémentaire. Déplacement élémentaire, basically they tell you to find the module, and module is just the same as the Pythagoras theorem. Like if you remember Pythagoras theorem. So it has the module of dl is equal to square root dx squared plus dy what squared. So this is just, you are just going to get, since you know that you should always note that each time a vector multiplies by itself, it always gives you a 1. You have to know this one. So you have seen here that it will be dx, it was supposed to be dx squared ax squared plus dy squared ay squared. Now you know that it will be ax times ax, which will give you 1, and ay times ay, which will give you 1. And for you to find the distance elemental, it will be dl is equal to square root, since this one has ex and dy, ay has been what? They have given you 1, meaning it's just the same as there's nothing. So it will be dx squared plus dy squared is what? Square root. So when they tell you to find a module or something, so these things you are going to understand them more when we do when we do some exercises, you're going to understand them more, like the point, what's the importance of us knowing these formulas and these points. Yeah, so here basically just have to know the point, what usually happens when a point moves from one point to another, and you have to know its formula. So you have to know this formula. This formula is really important, and you have to know how to come about it. How did it reach here? Since you know that it has moved from M to M prime, meaning that there's this formula O M prime minus C O M. Yeah. So you just have to know this one. So this one is déplacement élémentaire. Yeah, so the equation can come a point M move to a point so. Yeah, and calculate its déplacement élémentaire. You have to know how to calculate its déplacement élémentaire. So when you go to do when you do the questions, you understand it more and better. Yeah. Then now we're going to go. We're still under coordinate Cartesian. So when I say coordinate Cartesian, I mean the coordinate which can be. I'll be always repeating this one. The coordinate which can be represented, or the points, the coordinates, which you which is represented maybe by a rectangle, a square, not a circle. A circle, those they are called coordinate polaire. We are going to see for a circle. We're also going to see for a circle. So this one for coordinate Cartesian is basically always points which gives you straight lines, not something like a circle, a cylinder, a sphere. No, it's something which it's always a straight line. It will give you, for example, a triangle. It can give you, for example, the point can give you a rectangle. It can give you, for example, a square. It can give you those things. It's always a straight line. It's not a line which is somehow curving or what, something which is always straight. The points will always give you straight lines. So how do you calculate each surface elemental? Now we have seen where we're going now. How can you calculate each surface elemental? So we're still under coordinate Cartesian, so surface elemental. So we know that le vecteur déplacement élémentaire constitué en point M, la diagonale d'un rectangle élémentaire de côté dx et dy, portés respectivement par ix, and ey. These are, as I repeat, these are just direction, like how should we move? Is it up or down? Or yeah, if you see the direction which is up, meaning you are always moving up, like yeah, you're always moving up, then there's yeah, that's for EY, then EX sides. So here it's basically saying that the vector déplacement élémentaire constitué en point M, which is the point M, the diagonal d'un rectangle élémentaire de côté dx, et dy porté respectivement ex and ey and the surface surface elemental. For example, this is a point M, this is OM, and this point has moved to M prime. So we have OM prime. So for me to reach this point here, I can move, which is x dx and y dy. I'll reach this point here, which is this point. M prime. So for me to find, you have seen I've made something like a rectangle. This is a rectangle. I move from M to M prime under the x-axis, and from yeah, from what, from y to what, to M prime, which is in the y-axis. So for me to find the surface area, you know, for you to find the surface area, you have to do is it length times what, times breadth? Yeah, length times breadth, which is just the same as, you know, that this distance from here to here, we found that is what here, according to here, we found that after is, yeah, this one is just the same thing. You can, yeah, it's just the same thing. You can move up and like this. Yeah, up, down. So I found that it was dx and dy, which is, we know that after, if you want, you can do the calculation om prime minus m, or m prime minus om. You will find it is dx plus what? Dy, and yeah, dx plus dy ey. And for you to find this surface area, it means you just multiply the dx times the dy. Yeah. So basically, most of the time, if you are told to calculate the surface area, as long as you know it's the déplacement élémentaire, as long as you know how to calculate the déplacement élémentaire, and as long as it's xy and it is a coordinate Cartesian, you know that the déplacement élémentaire is always dx ex plus dy ey. This one never changes. It's always like this, whether a rectangle, a triangle, a square, it's always dx ex. And for you to now to calculate each surface area of a rectangle, you just get the side, which is dx times dy. You forget about ex and ey, which is direction. Yeah. So surface area, just you know, surface area. What makes I can say the area of which surrounds something. Yeah, the area which surrounds something. So for me to what, I know that this is dx times dy because it has moved dx and it has moved what? Dy. So for you to find this surface area is what? Dx times dy. Yeah. So under coordinate Cartesian, Danson plan, this is, I can say this is all about it. So we are going to look at coordinate Cartesian or coordinate Cartesian in a plan which is when they say Danson plan, it means there's only x and y axis. And we are also going to look at coordinate Cartesian, Danson space meaning in 3 dimensions. Yeah, so right now we're just looking at it in a plan. How do you locate the point, and how do you calculate the déplacement? How do you do all those things if you have the coordinates in a plan, which is the x and the y axis? So until there, I don't know if there's anyone who has any question before we go to coordonate polaire. Coordonate polaire, basically we're going to talk a point which is found in a circle, which is also an interesting thing. Like how do you calculate this déplacement, is movement, like the displacement, is displacement. How do you calculate this displacement? Yeah, yeah, which is the same thing as movement. So for now, before we go to coordinate polaire, which is coordinate polaire, do you have any question under coordinate Cartesian? You can ask so that when we answer, we forget about it. So if there's anyone with any question, you can ask me. Feel free to ask questions where I didn't understand.
I didn't get how you derived the other formula for m prime, is it?
Or like the movement from m to m prime?
Yes. Now how you came up with the other formula for dx ex plus dy ey, that one.
Oh, okay. Okay. So for this one, yeah, I said earlier that you have got a point which is m, like you have moved from O to m. Then from there, this same point moves to m prime. It moves to what? M prime. So this point which was on m, it moves to m prime. It's like you have a distance. So OY is a distance which is moving in the direction of EY. So you have this distance OY and you have this distance OX. And for you to move from M to M prime, it means that where there's Y here, you add another, I can say there's an addition which is taking place here. So this addition for you to move from here to here, you add a dy. So dy means basically to differentiate something, as I said, is to move from one place to another. Like you are doing some, I can say differentiation. Yeah, you are moving from one place to another. So from y, you add dy, which you have moved from m to m prime, and at x, you add what? Dx, which you have moved from what? At x, you have moved to, at x, you have moved to a new point, which is your x, your actual x, plus the movement which you have made, the movement which you have made, the x. Then now, how do you calculate, how do you derive the dx, ex, which is the direction, plus dy, the, yeah, dx basically is the new movement which you have made, times ex, which is the direction which you have made your new movement, plus dy is the new movement which you have made, times ey, the direction in which you have made the new movement. So how do you calculate it? So you see, you are calculating now, you want to calculate the vector m prime. So for you to calculate the vector m prime, you have to do, since you move from what? You move from, your starting point always is from O. So you have to calculate O m prime, the direction of O m prime, which is, for you to have O m prime, you have to move O y plus dy, or x plus what? Dx in the direction of ex, in the direction of ey, respectively. So you have to do, you have to calculate the difference between OM prime minus OM. So it will be like the difference between x plus dx. I will start. I will start by open brackets, x plus dx, close brackets, ax plus y, plus open brackets, y plus dy, close brackets, ay, minus now om, which you have already calculated. Om is just x times the direction, plus y times the direction, which is ay. So which is the same thing which I wrote here. Yeah, which is the same thing which I wrote here. I will said x plus dx, which is dx, the new direction, ay, which is this whole equation. I think you can see my screen sharing. This whole equation is presenting om prime, this whole equation, because I've from my x, I've moved the dx from my actual x, which was my initial. I've added the dx. That's why you're saying x plus dx, ex, times the direction, which is ex, plus y plus dy. From my initial distance y, I've added dy times ey, which is my direction, minus this whole is om, which is the direction, the what? The point initial, the point which is initial point. So initial point you have, for me to have m, I've moved the x and the y, So you see that there's x times the direction in which I've moved in, which if I think while I'm doing this, you should be imagining the direction which I've told you. So the x is moving towards the right side. So ex, so x times the direction plus y times the direction. And now for you to find the final answer, you have seen there's ex and the ex, which are common. So meaning I will group the common terms together. Then after grouping the common terms together, you'll find out that the xx will cancel out and the yy will cancel out. So if I remove the brackets here, it will be negative x ex minus y ay. And which, if I group the like terms together, it will be x plus dx minus ex, ex, which is common, times ex, the direction which is common, plus y plus dy minus y, ey, the direction which is common. So you see here that the x and the x will cancel out, the y and the y will cancel out, and you have dx ex plus dy ay. This is where now where the equation comes from. Dx, dx is just you are subtracting the new movement which you have made minus the actual movement which was there before, the actual movement which was there before you made the new movement. So the actual movement, you know that from x you add dx, and the vector of move more is always the same. The vector of ex is always up, and plus y plus dy. Dy, you know that the y you have added a new movement which is dy times the direction which is ey. Ey, the direction is always the same, minus x ex x ex x is the direction for you to have the point OM. So all this, as I said, is for point OM. Then y plus y times ay. Y is is the distance which you move to have the OM, and EY is what the direction. Then when you do your calculations, your what, you find that you have your dx, ex plus dy, ay. I don't know if it's clear.
Yes, it's clear. Thank you.
Yeah, and I'll send this PDF. I'll send it in the group so that you can just check the how to do the calculation. Maybe if you are stuck, all those things. I don't know if there's any other question. Okay, if there are no questions, we're going to go to.
Wait. So yeah. I have a question.
Yes, you can ask.
So does that mean we'll keep on learning without like going through the graphs with like numbers and whatnot? Because like just explaining in terms of math, it's kind of like confusing to learn without the numbers. Understand?
Yeah, like learning basically, I can say here in Morocco, basically they don't usually use numbers. Like they use letters. Like you'd find even mathematics, you'd find they use most of the things is letters, all those things. But you are going to understand more when we do TDs. The TDs actually they're in form of numbers. That's where even the explanation will even come more, because I've got some exercises. So TDs are exercises. I've got some exercises which explains, like, which are in form of numbers, and like that you are going to understand even more with numbers. So like right now is what is basically most of the things is in letters. That's how it is in Morocco. It's rare that they give like numbers, what in terms of the explanations. Yeah. So, but I know that when you do some exercises, you have a clear view on this, and and when you are done here, just do some research, try some exercises. If you want, I can give you the exercises after this this course so that you try them. If you do some after you have solved, you can send it to me. Then I'll correct where there's a mistake, and also like that. So we'll see if I'll be able to finish the coordinates on time. I can give you some questions also, just to see, and and we can the other time we can do it together. I don't know if there's anyone else who has a question. Yeah, so so if there's no one, we're going to go to coordonnées dans un plan. No, we're going to go to coordonnées polaires, but we are always in coordonnées dans un plan. Coordonnées dans un plan is, as I explained earlier, that's the X and the Y axis. And under coordinates in the plan, we have coordinates Cartesian, which we are from doing, and now we're going to go to coordinates polaire. So coordinates polaire is basically these are points, or these are coordinates which they can be defined in a circle, like a point which can be found in a form of like which can be found on a circle. And most of the time this point can move can be moving in the direction of 360, like moving around like a circle, this point, or this point can be moving like from one circle to another, like it changes position from one circle um, from one circle to another. So the direction of 360 is E theta, where you see here that, for example, the point was here. It will start like, it will be moving in a form of what? In a form of a circle. Then you can also move this point from here to another point, which is, which you can name it M prime. Yeah, you can move it to another point, which is, say, euro. Yeah, you can move it to other point, but you can move it to another circle in which it will continue rotating in that circle. So you see there that basically at this point, when this point is moving, it can move from one circle to another, or it can move in a circular form. Yeah, and when this point moves from, for example, from the from x-axis is increasing, you see that it will start creating like an angle, like like the way, if you can just imagine the way the circle is. The way the circle is, it has got if you draw the circle, it has got the point in the middle, which is, I can say this is the point O, and we have got the circle is cut into half. It's cut into half with the y axis, and is cut into half with the x axis. And here just the movement, like the radius, how the radius is moving. You have, for example, you have 190, 160, those angles like which are created in a circle. 190, no, 90, 60, yeah, those angles which can be created in the circle. So basically, the coordinates polaire is, it talks about a point which is, what you just have to know is coordinate polaire talks about a point which is moving in a circle. A point which is moving in a circle, and this point will be varying according to the what? To the angle, which is, if the point moves to another point like here, the angle will vary actually. Or if this point moves to another circle, the angle, or like if there's another circle outside here, if it moves from here to another circle, the angle will remain the same, but its distance will vary. So the radius will be varying. For example, you're moving, it's just the same. Just imagine you're moving from a small circle to a larger circle. The distance, the radius actually most of the time it varies. Then if we are moving around, the radius, you know that it always remains the same, but what changes usually is the angle. That's why you have the 90s, the 60s, depending where the point has moved. So under definition of body, considérons un point M appartenant au plan affini OXY, muni du rappel RXY. So we have a point M, which is found in the plan XY. Yeah, which is found in the plan XY, and we have got the direction EX and EY. So it's just the same as coordinate Cartesian. You have the direction, which is the vectors, which is EX, and what? EY and EX, which are the vectors. Then on appelait coordonnées polaires du point M le module P, le module rond. So le module rond is equal to OM appelé rayon polaire. So the module rho is this one, OM. This is the module rho, the distance OM. Yeah. So for coordonate polaire, this distance OM is called what? Rho. This symbol just represents rho. This, which looks like a P. Yeah, it represents rho. This is the distance OM. Yeah. Then you have got the angle which is created. So you have seen this is angle. This is theta. Yeah. Yeah, this is the sign for angle, which is theta. Yeah, the sign for angle. So you have seen this is an angle which is created here. So this angle is created between EX, the direction EX, and the distance OM. They're supposed to be O here. Yeah, the OM. So this is the angle theta. And this angle is called appelé angle polaire. The angle est compté dans le sens trigonométrique positif et prend sens value dans l'intervalle 0 to 2 pi. So 2 pi basically is 360. So this angle, it can start from 0 meaning on the x-axis, to what? 360, meaning it can the point can start from the x-axis, which is 0, then it can go around until making a turn, which is what? 360. Yeah, 360. So basically that defines coordinates coordinates polaire. So coordinates polaire, you have to know that there is a radius. So these are the things which you have to know under coordinates polaire. There's a radius which is called rho, and there's an angle which is the difference when the point is moving around a circle. So these two things are really important when you tackle coordinates polaire. So coordinates polaire, first of all, when you are given a question, you have to check your question first. Is it defined in X and Y? If it's defined in X and Y, and it's a form of a circle which is defined in X and Y, there's no Z. Z is 3-dimension. You know that you are using a coordinate doesn't plan, and since it is a circle, you know that here I have to use what? Coordinate polaire. So right now we're going to see the déplacement, we're going to see the formulas of the coordinate polaire, so that when you have a circle which is only defined by X and Y, you know that I'm using this and this formula. So the most important thing, you have to know that which formula am I using. So first of all, you have to check your question. You have to check what things they have been given, and like they have given you what information have they given you. So most of the time, coordinate polaire, yeah, I can say it's a base of coordinates cylindric and coordinates spheric, which you are going to look as you go further. We are going to look at we're going to see that coordinate cylindric, coordinate spheric. But for you to understand coordinate spheric and coordinate cylindric, you have first to understand the coordinate polaire. So coordinate polaire is just the movement of something in a circle. Yeah, it's I believe if we are able to be like, if it was a physical learning, I would have demonstrated it more properly, because it basically it involves something, a point which is like just moving in a circle. So for you to remember coordinate polaire easily, just know that it's a point which is moving in a circle. A point which is moving in a circle. You know that here we're talking about the coordinate polaire. Then coordinate Cartesian, this is a point which is not moving in a circle. It can move in any other shape, but not a shape which is in the form of circular, which is a shape which is curving. So coordinate Cartesian, you can give a rectangle, triangle, those things. Then coordinates polaire, something which is moving in a circle. Those are the things which you have to put in mind. So we're going to continue. We're still on coordonnées polaires. So la base du système de coordonnées polaires, I θ est une base définie à partir de la position du point M. So you should know that the direction, the bus, as I said earlier, the bus, it means direction. The vectors echo and I theta, they are always placed on the point M. So this I theta, it shows the direction of where it shows the direction of where this point will be moving around the circle. So you see that it will be the direction where this point will be moving around the circle, and you see that this direction is defined in a circle. Like the core never changes really, because if you're moving around the circle, the distance from the center to the, like for example, imagine that this is a circle. This is a point which is on a circle. You know that a distance, a radius doesn't change. Wherever you move on a circle, the radius usually doesn't change. So I theta is just the movement of a point on a circle where the radius, which is in this case, don't be confused when you see this symbol rho, which is in the form of P. It's in other terms, it's just a radius from O to M. This rho is just a radius from O to M. So here, basically when you're talking about coordonate polaire, we talk about radiuses. We talk about the radiuses. Then when we're talking about coordinate Cartesian, we talk about distances. We don't talk about radiuses with coordinate Cartesian, because we see things like rectangle, those things, rectangle, triangle. There, you just talk about the distance of something, and a radius, it's mostly it's related with a circle and all those, with a circle, a sphere, a cylinder. So where you see a circle, a cylinder, we talk about radiuses, and this radius is basically represented as a whole. So this symbol which you're seeing here is just a radius which is represented a whole. They just wanted to present it in a form of a whole. So you see that this distance, it will always they'll be using if you go like further, you see under coordinate, cylindric, spheric, you see that this rho can change to maybe red R what. It's just a symbol which is to represent the radius actually. So you see that I theta is is placed on M, and this I theta is it gives a direction in which a point will be moving around the circle. And when a point is moving around the circle, you see that you notice that your angle, which is theta here, will be changing, but your distance will never change. So the only thing which will be changing is your angle. Yeah, that's why you see here. Si le poids est en mouvement, le vecteur IP, et par conséquence, I theta changer de direction. So here you're going to see that si le poids est en mouvement, le vecteur IP, et par conséquence, I theta change de direction. So you have to know that when a point is in movement, imagine this is a point. Electricity is more about imagining. Imagine this is a point. You have a direction which is I theta. I theta, it is the movement of a point in a circle, and the I rho is the movement of a point from one circle to another circle. It's possible for you to, like, I can say it's the same way as déplacement. I rho is the same way as under where we looked at the coordinates Cartesian, where the point moves from M to M prime. So here it's just it will move actually from M to M prime, but the distance, the direction which it will move, it's defined by I rho. Yeah. So now imagine this point M is moving around the circle. It's moving like this point M it's moving around the circle, like it's moving around the circle, you see that this distance, this direction, E theta and the E rho, they will be in constant changing. Because, for example, if M comes here, the E theta, it will come like the direction E theta, it will be, I can say it will be more horizontal than the way it was at M, the initial one at M. And the more it's moving, the more it becomes horizontal, then it will, the E theta will start looking down. Then as you go down, you see that the direction of E theta and E rho, they will be in constant what? Changing. Le base est mobile. So here we say that the direction is what? Mobile dans le rappel. So this is really important because you have to, there's a difference which comes in here, because there's, if you remember, under the coordinates Cartesian, we said that there's a direction which is EX and EY, which are here. And we said that these directions or these vectors, they are constant, they are not in movement, because how can I say it? These distances are constant in such a way that they are always moving. They're always moving on the EY is always moving in the Y axis, and the EX is always moving in the X axis. But you see that this one, E theta, is always in changing. You see that as the point is moving, because this direction, E theta and E rho, they're always in changing, because they are placed under point M, which is a point which is always in move more. This point M is not on the, I can say it's not on the fixed point. It's always moving. But the Y and the X axis, these are the axes which are fixed. Like you can never, they don't move. So you see that the base EX and EY, they don't really move, but the bases E theta and E rho, they are always in move more. So for you to be able to get this really well, just imagine a point which is moving in a circle, a point M which is moving around the circle. You see something like, if you imagine, you see E theta somehow moving with point M, E theta and E rho, E theta, which is E theta, and E rho somehow moving with the point M. Where the point M is moving, that's where the E rho and E theta is moving. But for coordinate Cartesian, you see that where the point M moves, EX and EY doesn't move. Whether I move point M to infinity, or I move point M to any direction which I want. I can move it to this side, the other side. My vectors EY and EX will always remain the same. But for E theta and E rho, when the point M moves, the vectors also, the E theta and the E rho, the direction changes. So it is constant changing. So when the direction is in constant changing, we say that the base is mobile. But for coordinate Cartesian, where we see that EX, EY is not moving, the point M can move any point, but it's not moving. That one we call it the base. I can say is the base which is immobile, which is not changing. It's always moving in the same direction. So we're going to see that ces vecteurs peuvent être représentés n'importe où dans l'espace, mais ils sont représentés souvent soit en point origine O, soit en point M lui-même. So we see that these vectors, E theta and E rho, if I want, I can present it anywhere in the line OM. Yeah. They can be presented everywhere, anywhere, but they can be presented at the origin O or M. But the best thing which you can do is just to present it at point M. Present them at the point M, because when you present them at point M, you'll be able to see clearly what's happening when the point M is moving. What's happening with the direction. So these are the things which you have to know. So under coordinate polaire, you have to know the radius what happens when a point is moving, what happens to the radius when a point is moving in a circle, or it has changed from one point to another. So when a point is moving in a circle, we know that the radius, which is rho, is always the same. When it jumps from a point, it moves from one circle to another circle, another different circle, which is from a small circle to a bigger circle. We know that rho there will change. There will be a changing of a rho, and yeah, there will be changing of the rho, but the radius will be just the same. Then no, there'll be changing of the radius, sorry, but the angle just the same. Then when we move when yeah, so those, I can say those two things are the things which you have to know. The rho, the changing of the rho. When does the rho or the radius changes? It changes when you move from a small circle to a bigger circle, or from a bigger circle to a small circle, from one point to another. That's when the radius changes. Then when does the angle change? The angle change when you're moving in a same circle, which is, I can say, yeah, a same circle, but you are changing the point of M. There you are going to see the change of what? The change of angle. So those are the things which you really need to know and to get. So that's the principle of coordinates polaire. Those are the only things you have to know. If you know those things, you won't have any difficulties in coordinates polaire. So yeah, we're going to continue with coordinates polaire. So definitions. So the vector's position OM peut the vector's position OM peut s'écrire OM is equal to rho fois I rho. So for you to have this point M, you have to do a movement. So this, since as you said, this is a circle, you don't do a movement as if you are doing a Cartesian. Cartesian, we said, for we deal with distances for Cartesian, but for circles, we deal with angles and radiuses. So for me to reach to point M, meaning I have to move a certain angle. For example, if my point was here, it means I have to move a certain angle, which is here. Then, yeah, it means I have to move from this point X to, I move a certain angle, which is here. Then I'll move from O to M, which is the distance to come. So for me to find my OM actually is this distance rho, the radius, rho times its direction, which is A rho, plus theta times its direction, which is E theta. And since we have said that this point is moving in a circle, when the point is moving, this point is moving in a circle, meaning the radius doesn't change. The radius doesn't change, and there's a direction of this one which is changing, and basically most of the times you see that when for example, when you are moving in a circle, when you're moving in a circle, the distance between O and M doesn't change. O and M doesn't change, which means that if the distance O and M doesn't change, there's no effect really, which is expressed on this point, because this point is moving, is always moving inward. I can say it's always moving at a point which gives you the same radius. So there's no effect in a circle. For example, if I can give, for example, let's say this point M is positive and this point O is negative. and I'm moving this point M. When I'm moving this point M around the circle, meaning the attraction between the negative and the positive will always be the same. There will be no difference in the attraction because the radius is always the same. So we see here that when I'm changing theta, most of the times when you're changing theta, theta meaning when you're changing the angle, when you're moving around, you're changing the angle. Actually, nothing really changes in terms of the attraction between or the distance between OM. Nothing really changes, and we say when nothing really changes, we say that this point is constant, and when a point is constant, it's always equal to 0. The change mode is always the different. If you differentiate, if you differentiate 1, you get a 0. That's why you see here you have OM is equal to P E is equal to rho times E rho. They were supposed to be plus theta times E theta. Now theta is 0 because each time I'm changing the angle. Each time I'm changing the angle, the distance is always what? The same. Nothing will really affect. Now for theta, if for example, if I change theta, no, if I change rho, what will happen if I change rho? You have this distance from here to here, radius. Then I move, imagine this is M is positive or is negative. Then I change this point from O to, I go to a bigger circle. So it means that the distance has increased, meaning something has changed, meaning the attraction between O and the M has changed, meaning even the radius has changed. Something has changed here. You see that the radius has changed and even the attraction has changed. So you see there that rho actually has an effect under for point M. Rho has an effect for point M. That's why you see rho, you can rho, it will never give you 0. It's something which is which affects the circle. So you understand more this when we look at the charges, the what. That's why you talk about the positive, the negative, those things. So here you just have to know that what defines coordonate polaire. If you want to calculate your OM is just equals to rho times the direction. It's just equals to, your OM is just equals to, in other terms, it's just equals to the radius, which is rho, times where the radius is going, which is rho, in other terms. Then for you to calculate OM meaning you are calculating the module. The module you here, how do you calculate the module? You know that rho is for you. If you check here, rho is the radius which is creating a distance, which is OM, and M what? MX. You have OM and the MX. So you are creating like a triangle here. So for you to OM is just the same as x squared plus y squared, square root. So this is just the same as I can say Pythagoras. For you to calculate rho, for you to calculate this distance here, I remember in Zambia we used to use the Pythagoras theorem. So for you to know the distance OM, it's just the same as x squared, which is the distance here, plus y squared, which is the distance here, square root, then you have your distance. Then what is the relationship between polaire et cartésien? Relation entre polaire et cartésien dans un plan. So what is the relationship between what? Coordinates polaire and the coordinates what? Cartesian. So you have to know the relationship between coordinates polaire and coordinates what? Cartesian. So what is the relationship? So you know that under coordinates Cartesian, under coordinates Cartesian, you know that x is equal to OM times AX, or x is equal to OP, x, the distance x here, the distance x here, this distance x here is equal to what? OP, which is equal to OM times EX. I don't know if you remember how we calculated this one, where we said that imagine there's an angle here. Yeah, we said that there's yeah, for example, there's an angle here. Then for you to know your EX is adjacent over hypotenuse, and your adjacent is EX. Your adjacent is X, which is X here, divided by, yeah, is X divided by OM. Then you have your X OM times EX.
Could I ask a question now?
Yes, you
so OP is equals to OMEX because of SOHCAHTOA, right? If I'm not mistaken.
Like yeah.
Could you just explain that part? Could you explain it more in detail?
Okay. So I think you remember this one, we've already done it. So this is under coordinate Cartesian. Yeah, coordinate Cartesian. So under coordinate Cartesian, actually, here we don't, under coordinate Cartesian, we don't deal with angles. Yeah, so you have a distance which is X, you have a distance which is what? There's OX and OM. So this distance is just called X, and this distance is called what? OM. So now for you to what? To find your direction. For you to find your direction is your EX. For you to find your EX, you have to because basically most of the time EX is what is I can say is taken similar as to the what, to the, like I can say, to basically most of the time the direction EX is just taken similar as the angles seen what under SOHCAHTOA. That's why I've used SOHCAHTOA, but you don't need to use SOHCAHTOA. EX most of the time is taken as for example, for me to calculate EX, we'll consider like there's an angle here. So for me to calculate EX, what I do, since this point has moved from this point to M here, meaning it has created a sort of an angle. So for me to calculate EX it will be, since there's a sort of an angle, this is OM is always hypotenuse, and the EX, where the angle is like touching, is adjacent. So I know that my EX my X will be what? My X will be acting as the adjacent, which will be on top, and my OM will be down, which will be as ash. Then my cos will be just represented as EX. My cos will be represented as EX. Since the point has moved from this point, like the point is in movement, it has moved to here, M. Yeah. So EX will represent cos, X will represent the adjacent, and the OM will represent the hypotenuse. Yeah, OM will represent the hypotenuse. Then now if I do the calculation, the cross multiplication, I'll have X, which is equal to OM times EX. And this is where the X is equal to OM times EX is coming from. And then we have said that EX is just is presenting the cos. Yeah, we just represent it as EX, because in coordinate Cartesian there's no the cos, sine, all those things. Then for EY is this distance here, which is just the same as this distance here. The angle is made here. Yeah, attention, the angle is made here. Imagine the angle is made here. So it means it will be EY, which will present this side will be opposite, this side will be what? Hypotenuse. So you have sin or ash, where EY represent the sine, EY represent the sine, Then Y represent the opposite, which is this side, the distance this side, and the hash represent the hypotenuse, which is OM. So when you do your cross multiplication, you have your Y is equal to OM times AY. That's how and this is under coordinates Cartesian. This is under coordinates Cartesian. Now, what is the relationship with now? What's the relationship with what with the coordinate polaire? Coordinate polaire, the relationship is just where there's OM here. You have seen the OM here. You write the same thing, but where there's OM here, you replace it by what? By rho, by radius. Since you have said that coordinate polaire is defined by radius, which is represented as a rho, and the angle, which is can be represented as cos theta, sin theta, depending on SOHCAHTOA. So we have said that this OM will be represented by what? Rho, and this EX, since the angle is made here, if you see the angle is made here, this is where the angle is made. So it means the EX, the direction, is replaced by what? You know, the EX, this is the X, this is the rho. So for you to find this one, it will be X. Yeah, it will be X over rho, or X over OM, which we did, OM, which is this one, is equal to cos theta, where EX will replace it by what? Cos theta. So EX will be just replaced by what? Cos theta. So it's just the same thing. If you do the SOHCAHTOA, you find that this one is cos theta, the EX and the OM is rho. The same thing with Y. Y, if the way we've done it, it gave us OM, AY. OM, which is OM, the radius, I'll just replace it by rho, which is here, and the EX, EY is this side, which is, you know, the angle, the theta is made here. So EY is opposite. So meaning it will be opposite over hypotenuse, and you know SOHCAHTOA. So sine is equal to opposite over hypotenuse. So it will be sine theta is equal to the opposite, which is Y, divided by the hypotenuse, which is rho, which is your Y is equal to what? Rho times sin theta, which is the theta here. Then the X, which you know that the OM is this distance. Then the EX, you know the angle is here. So the X, the angle is here. So meaning it will be the adjacent and the hypotenuse. And you know, under SOHCAHTOA, there's K, which is adjacent over hypotenuse, where the adjacent, our adjacent here to be X, which is on top, divided by the hypotenuse, which will be rho, is equal to cos theta, where if you do the cross multiplication, you have X is equal to rho times cos theta. Yeah, that's it. That's where the rho cos theta and the rho sin theta comes from. I don't know if it's clear. Don't know if I can repeat or it's clear. Can I repeat?
Yes.
Okay. Yeah. So what I was like, here basically you don't really need to to confuse the things. I just so we are trying to the best I can say the base is we are trying to create a relationship or a relation entre polaire et Cartesian. And as I said earlier, under polaire, under Cartesian, we know that for you to explain better, return to the previous photo. So so this is under Cartesian. So first of all, you have to understand how we came up with OM times EX for Cartesian for you to understand the relationship between what the polar and the Cartesian. So we know that for polar, for Cartesian, coordinates Cartesian, for you to have this point M, you have moved the X distance and the Y distance. So you're forming like a triangle here. You're forming like a triangle. This is a triangle which is formed. And I said that under Cartesian, basically we don't deal with angles. So where I was supposed to write cos, I'll instead of writing cos, I'll just write AX. Or where I was supposed to write sine, instead of writing sine, I'll write AY. That's what I said before we started doing this one. So EX is the direction and EY is the direction. So how can I calculate my direction, which is EX? So calculate my direction, which is EX. I've said EX is equal to the angle. EX is equal to, just know that you should know, while I'm talking about this, you should know that EX is equal to an angle, which right now we don't know. So there's a direction which EX and DY, they are equal to angles. So there's, this point moves in the direction of EX and in the direction of EY, in the distance of X and in the distance of Y. So how do you calculate your EX? Your EX, which you have said is equal to an angle. So I will just, even though there is no angle, you imagine this point here, it has moved from X to M and it has created a sort of an angle, and this angle is equal to what? EX. So when you create an angle here, when you create an angle which is created between OM and the OX, the angle which is created here, you know that when you create an angle here, this angle is between the line which is OM and the line which is OX. And if it's between the line OM and OX, meaning where this angle is touching, the lines where this angle is touching, you have OM, which is always the hypotenuse, and since this angle is touching the OX, the OX will become the adjacent. I think that's in you know it. So if OX, the distance X become adjacent and OM becomes what? Hypotenuse, and you know that this angle is for me to calculate EX, I have to calculate the angle which touches the line OM, which is this one, and the OX, which is this one. This is the angle which is what created. So for me to calculate my EX is equal to the adjacent, which is X, over the hypotenuse, which is OM. Then when I do my cross multiplication, it will be X is equal to OM times EX. Then when you go to EY, you see that under EY, you have EY. For you, I've moved this distance X and this distance what? M. This distance X and this distance Y to arrive at what? M. So EY is represented as since there are no angles, it's basically most of the time it represents an angle. So for me to have EY, and we know that the angle is made between OM and the X. The angle is always made between here because you are like, the point is moving in such a way that it's opening. It started from, you should be imagining that it's starting from the X-axis and it's going up. It's starting from the X-axis, meaning it's opening from the X-axis, meaning the angle which is being formed here is formed between OM and the OX. That's where the angle which is formed. So you know that for me to find my EY, it means I have to, this distance Y and the hypotenuse. And I know that this Y is opposite and the hypotenuse. And which one do I use, Daisy? This one, opposite over hypotenuse. So it will be EY is equal to Y over OM. And you know that EY, here in such a case, EY represents sin, and here in such a case, EX represents what? Cos. Then when I do the cross multiplication, it will be X is equal to OM times EX, Y is equal to OM times EY. So OM, this is where when you go to Polaire now, we have said that the OM, it represents rho, the radius OM. Then EX, it represents what? The EX, it represents what? The angle, which is cos theta. Yeah, the angle, which is what? Cos theta, because this angle is made here. So if it's made here, you know that EX is what? Is cos is equal to adjacent over hypotenuse. So EX is just cos, then OM is rho. Then Y also, Y is equal to OM is 2 rho times EY. EY it represents what? It represents, I can say EY, it represents the opposite here. Since the angle is made here, the angle is made here. So you have opposite hypotenuse. So opposite hypotenuse, you use what? Sine. So you know that sine is equal to opposite hypotenuse. EY is equal to opposite hypotenuse. So EY is replacing what? Sine. So you know that when you come here, this will be rho, this will be what? Sine. That's the relationship. Like, because for coordinates polaire, you deal with angles and you also deal with the radius. That's what you deal with. Yeah, so it's the same thing here. You see, it's just the same triangle which is created here. Yeah, just the same triangle which is created here, where I'll just replace the OM with rho because I'm dealing with radius. This is OM. Then EY for EY I've replaced with what? Sin theta, which is, you know that your EY is the distance which is here, the opposite. Sin, you know, sin, yeah, opposite. Then we go to X OM, I've just replaced it with rho. Then EX, I've just replaced it with what? Cos theta. Yeah, I think you'll more understand it if you just try drawing a triangle, then use the Sogatoa method. You use it on coordinates what? Cartesian, and where there's maybe sine or cos, replace it by EX. Then you use it with now coordinates polaire. Then where there's EX, you replace it now by the actual angles, because there in coordinate Cartesian, you don't know the angles, you just represent them with EX or what. The angles are not really, most of the time they won't really ask you to calculate angles with the coordinates Cartesian. So only coordinates polaire, all those things, yeah, those things. I don't know if it's clear. Hello?
Some things are not clear, but we are going to rewatch since you are recording this lesson.
Yeah, the best thing is to rewatch it and to rewatch it, and also try to to pass through it immediately when you are done. Just try to pass through it. You try solving, and where you have a difficulty, I hope all of you have my number. Yeah, I know all of you have my number. So if where you have a problem when you're studying, just text me, and there I'll explain it better to you. Like, yeah, you can text me after you have passed through, after you've studied it through. You won't, even when I'm explaining to you, you get the things easily. Yeah, you get the things easily. So just try to pass through it, and you see that these things are actually things which are really simple. Like you just have to, yeah, you just have to do more and more practice. And basically, electricity, the way it is, it needs the teaching most of the time. It needs uh, someone writing, like while we are teaching writing, and yeah, and it's I can say it's very difficult to do it on online while you're teaching. The writing thing can be made more easily if if what if if I'm teaching you guys physically, like yeah, if I'm teaching you guys physically, that's where I can be more effective the writing one. But the online one, we have those, yeah, those things like some small difficulties in terms of we are limited in terms of things what to do. Yeah, so I'm going to continue. So you have to pay attention one thing. Ne pas confondre coordonnées polaires d'un point et un composite d'un vecteur positional de ces mêmes points. So here they're saying you should not what you should not confuse the coordonate polaire of a point and the component of a point. So coordonate when I talk about give me the coordonate polaire, I mean what coordinates which coordinates can allow me to have the point M, which coordinates can allow me to have the point M. So for me to have the point M, I have to move a certain radius, which is rho, and I have to move a certain angle, like you are opening something. For example, imagine yeah, imagine you are opening what? You are opening a book, like that book, while you're opening that book will be making an angle until it is open complete where to make, I can say, approximately 180 degrees Celsius, approximately 180 degrees, sorry, which will make 180 degrees approximately. Yeah, so when you're opening a book, it will always be making what? An angle. So you should know that it's the same with a circle. A point can start at the x-axis, for example. Then this point will be moving until it reaches what? Y-axis, where it becomes somehow like 180, then it moves, and it comes again to point M, where it makes a 360 revolution. Yeah, it makes a 360 revolution. So the point M is the coordinate polaire of a point M is rho, which is the radius, and the angle, which is in constant what? Changing. Les composantes du vector position OM, so rho, and this one was here. Yes.
You said for the for the polaire, you said the angles in constant changing together with the radius. But yeah, if I remember clearly, didn't you say the radius is always the same for the polaire?
Yeah, I said if I remember correctly, I said if you are changing, if for example, the point M can move in two ways. The point M can move in two ways. That's what I said. I said the point M can move around like it's moving around the circle. And when it's moving around the circle, you know, if the point OM, the point M is moving around the circle, the radius is always the same. The one which is changing is what? The angle. The angle is the one which will be changing. That's what I said. And from there, I also say that you can also move the point in such a way that it moves from a small circle to a bigger circle. When it moves from one point, like for example, I can say, lack of better terms, it jumps to another circle. There you see that if it's in the same line, for example, OM, it moves maybe here, this point, you see that the angle will remain constant, but the radius will change because I've moved to a bigger circle. Then I continued explaining that. Now, like when you are calculating OM, I continue to explain that when you're calculating OM, basically, for you to calculate OM, you have to do the radius times its direction, which is equal plus theta times its direction theta, which is this one, times its direction, which is e theta. Now, theta is 0 in such a way that imagine in this case, this is like we have moved away from moving from one circle to a smaller circle to a bigger circle. Now imagine this is a point where we've said that if a point is moving in a circle, the radius doesn't change. When the radius doesn't change, it means that for me to calculate the OM, it means that if for example, before I change the radius, just imagine OM, before I change, I go to the bigger circle. If I'm moving around the circle, I said nothing really changes because the radius will be the same, and the radius will be the same, and the theta will be the one which will be changing. And when the theta will be the one who's changing, but the radius will be the same. But I gave an example of for you to really understand it, why they just use rho times e rho instead of why theta is 0. They say that, for example, if I gave an example, for example, if this is the point M is positive and the point O is negative, the distance here, you know, there's attraction between a positive and a negative. And I'm moving around the circle where the radius is constant. I'm moving around this. Imagine you're moving around the circle where the radius is constant, meaning at any point where this point M will be, the attraction will still be the same. I can give an example of an electron and a proton. When an electron is moving around the circle, which is the same radius, the attraction is always the same. The attraction is always the same, meaning the theta here, whether I change the theta, nothing changes. Like the force between this point O and M is always the same. Whether I change the angle, the force never really it doesn't change. The force doesn't change, which means that my theta here is in form of is somehow constant. And when it's somehow constant, you know that if you differentiate something which is constant, it always gives you 0. Differentiate because this point is moving. I can say this point M is moving. Is changing direction. Is changing the angle. So meaning is differentiation, meaning the changing of a point. But this point is on the same circle, and the attraction is the same. So the theta will be constant. But let's imagine another case where this point M here moves outside of the circle, the initial circle, it moves to another circle. What will happen? This is a positive, this is a negative. So the more you go away from, the more a point goes away from another point, the more the attraction becomes lesser. So you see there that rho has an effect. If I move the radius, if I change the radius, there's an effect which is being created there because the attraction is somehow changed, the attraction is somehow reduced. But when I'm moving around the circle, when I'm changing the angle, the attraction is always the same. The attraction never changes, meaning the theta is the movement, the direction of E theta is always constant, which means that if I differentiate E theta, it will always be constant. But M is, that's why they're saying here, M is always defined by two coordinate polar, which is rho and theta. This is what defined it. But the composite are different in such a way that the composite is something which I can say a composite is something which makes a difference when you change it. It makes a difference. You see that theta, whether I change theta in the same circle, no difference will be shown because it will be the same radius, the same everything. It will be just changing the direction, but the attraction will always be the same. That's why you see that it will be what constant, and the theta will be taken in form of a constant. And when you differentiate the constant, that's why you see it will give you 0. That's why you see if they say give the composite here, you see rho 0. Yeah. So I think for today, since my time is done for today, I'll finish here. We're going to we're going to continue from here. So before I go, I don't know if there is anyone with any question.
So
Mm-hmm.
Are you going to send the book to the group?
What? I can't get you.
Are you going to send this book to the group?
The what? I can't get you, I said?
I'm saying you are going to send this book to the group.
I think I already sent this book to the group.
The same book
Just
you're
check.
using?
Yeah, I already sent it. It's there in the group. Yeah, I'm saying that I already sent in the group, but I'll send it again.
All right.
Yeah, so if there are no questions, I think I'll leave you. Yeah, we're going to meet on, I'll inform you, I think on Wednesday. That's why I'm going to meet to continue with our lesson. And yeah, and feel free, if you pass through, make sure I just pass through fast. And if you don't understand, you can feel free to text me then where there's a problem, I'll try to explain. Yeah, have a nice day, everyone.